students in grade 7. Today we are going to make a quick revision for the contents in the first term, starting with the unit 1, lesson 1, with the title The Structure of the Atom. Before explaining the structure of the atom, let's remember that the smallest building unit of matter is called the atom, and the smallest building unit of the living organisms is called cell. And don't forget that the ancient Greek, said that there is a smallest particle inside the matter which is invisible. Then Dalton was the first one who put the theory about the structure or the model for the atom, and then the Rutherford who discovered the positive protons inside the nucleus. Let's remember how can we draw the atom to remind well the structure of it clearly way. When we draw the atom, first we draw the nucleus. We know that the atom consists of the nucleus, which has positive particles inside it, and we can call it as protons. And also has neutrons, which has a neutral charge, and also the electrons that revolve around the nucleus in an imaginary regions which are called energy levels. And don't forget, although the electrons has a neglected mass, but we cannot neglect its charge, as they are the negative charges particles that revolve around the nucleus in an energy level. And also we talked about how can we distribute the energy levels, actually the atomic number. For example, if we have an atom, for example as the sodium, which has atomic number 11, when we distribute it first, I have to write inside the nucleus the positive protons, which is 11, the neutral neutrons, which is 12, as we see. Then we will distribute the energy levels K, L, M, 2, 8, 1. So when I distribute the atomic number, I can use the rule, which is 2n power 2, to distribute the atomic number, which is equal the positive protons inside the nucleus. Then we talked about the lesson 2, the periodic table of the elements. When we started this lesson, we started talking about the classification of elements by a scientist called Mendeleev, which arranged elements in an ascending order according to their atomic number. Then Moseley arranged the elements according to their, Mendeleev according to their atomic weight, while Moseley according to atomic number, and also added the zero group, which is known as the inert gases, at the last group. And finally, in modern periodic table, there is a scientist called Bohr, and Bohr discovered the main energy levels, their symbols K, L, M, N, O, P, and Q. And also the main energy in the modern periodic table, the elements are classified according to their atomic number and also the way of filling energy sublevels with electron. Then we talked about the modern periodic table. It consists of 7 horizontal periods and 18 vertical groups, starting from letter A to 18. And also we ended this lesson by the naming of each group. 1A called alkali metals, 2A called alkaline earth metal, in the middle the transition elements that are located in the D block, and then the P block elements have the halogens, which are called in 7A group, and also 0 group, we can call it as 18, which contains the inert gases helium, neon, argon, krypton, xenon, and radon. Also in this lesson we ended by the comparison between the alkali metals and the halogens according to their high boiling point, melting point, and also their atomic radii, which called the atomic radius. And when I drew the nucleus and drew this line, this is the meaning of atomic radii. Also we talked about the Lewis dot structure and how can we distribute the atomic number. By the way, Lewis used the atomic number, all actually the electrons that are located in the last energy level. For example, calcium atom has 20 protons as its atomic number is 20. If I draw it in Lewis dot structure, so I will write Ca and I will distribute only the last energy level. So when I distribute it to A, it's A2. So by doing in the Lewis dot structure, it will has only 2 dots. This for the Lewis dot structure, and this is the end for lesson 2. Then we started in lesson 3, matter and its properties. Starting this lesson, the difference between the homogeneous mixture and also the heterogeneous mixture, the difference between the elements and the compound, the physical properties like density, viscosity, melting point, boiling point, thermal conduction, we can say heat conduction, and also the electric conduction. And the second part talks mainly about the chemical properties, like when we can use the reagent to distinguish between the substance with different colors, or even the litmus paper and its effect for the lemon, or even for the toothpaste. Also, we talked about the aerogel as a chemical property which contains 99% of the air, and also the scientists or the researchers in the Antarctica can use the aerogel in making their jackets to keep them warm. In this lesson 3, we end this lesson by some importances for some elements, like the importance for the helium, for the hydrogen, for the nitrogen in making the frame of the cars, aluminium titanium alloy in making the frame of the aircraft, as it can resist the temperature, and also it's the heat insulator. And don't forget that we have something called metalloids. Metalloids have properties of metals and non-metals. So the silicon at this part in this lesson, its main function, it can conduct electricity better than the non-metals, but poorer than the metals. Let's start a lesson 4 about talks mainly about the chemical bonds. We have 2 types of bonds here, ionic and covalent. Excellent, grade 7. In the ionic bond, we have the cation and also the anion, the positive metal for the positive ion for the metallic element, and the negative ion for the non-metallic elements. There is an electric attraction here happens between them, forming the ionic bond. For example, the most common ionic compounds are NaCl and also MgO, magnesium oxide, the CaO, calcium oxide. And don't forget that the number of positive ion must be equal to the number of the gained electrons in the negative ion. For example, the most common one is the sodium chloride, or we can say the table salt. So when the sodium lose, first if I distribute it by using the Lewis dot structure, number 1, and the chlorine has 7. So the electron here will go to the chlorine, so it will be completed and has 10 electrons, and also the chlorine will be completed in its last energy level, and also it will have the 8 electrons, so it will be NaCl, or we can say Na positive and Cl negative, and the number of charges equal the number of electrons. The positive charge equals the number of lost electrons, the negative charge equals the number of the gained electrons. Then we talked about the second type of bond, which is called covalent bond, that arises between the metallic element, the non-metallic elements, between 2 non-metallic elements. Their types are single covalent bond like hydrogen molecule, a double covalent bond like oxygen molecule, a triple covalent bond like the nitrogen molecule. And also in this lesson, we end this lesson by the carbon chain, which may be straight, cycled, or even a branched chain. That's for Unit 1. Let's start lesson Unit 2. Starting with lesson 1, the electric forces. We started this lesson by the meaning of the electrostatic force. It's a type of force or charges that accumulated on the surface of the object that are charged by contact or even by friction. And we defined the electrostatic series as the series that the elements are arranged from the elements that gained electrons and has negative from low, and then end at the top of the series for the elements which lost electrons and have positive charge, starting with the glass and end with the wood. Then we talked about the importance of the electrostatic plating and also the importance of the electroscope, which is used to determine the charge of the object that has charged already. And don't forget the divergence of the golden leaves inside the device, at which time the divergence increases and at which time the divergence decreases. And also we talked about the importance of the chains that are left on the ground to prevent the fuel combustion. The second lesson talks about the magnetic force, and as we know that there is a magnetism force in which the area of the magnetism force appeared in it has a magnetic field, and we classify the materials according to the magnetism force into magnetic materials and also excellent non-magnetic materials. Also, we talked about the magnetic field lines. They are an imaginary lines that don't intersect with each other and started from the north pole and ends at the negative pole. In lesson 3, we talked about the gravitational force, but when we started this lesson, we classified the forces into field force that has a field and contact force that has no field. The field force are electrostatic force, magnetism force, and also the gravitational, while the contact force are the collision and the elasticity force. Also in this lesson, we learned how can we calculate the weight of the object on the earth by knowing its rule, which is equal mass times gravity. And the value for the gravitational field intensity as it's given in the problem. If it's given for you with a 10, so you can compensate it by 10. If it's given you in the problem by 9.8, so as you have in the problem, as you will put it in the rule. For example, if the mass of an object on the Earth's surface is 9, so its weight on the Earth equal 90 Newton. That's for the weight on the Earth. How can we calculate the weight on the moon? Weight on the moon equal weight on air times 1/6. And don't forget that the gravity on the moon decreases by fixed about the gravity on the Earth. That's for Unit 2. Let's start in Unit 3 with a title, The Living Organism. And lesson 1 was the title Cells and Life. And when we started this lesson, we classified elements according to the number of cells into unicellular organisms like amoeba, euglena, paramecium, and multicellular organisms like humans, animals, and plants. But the second part of the lesson classified the living organism according to the presence of the nucleus into prokaryotes, that the nucleus is distributed through the cytoplasm, such as the bacteria, and eukaryotes, that the nucleus is surrounded by a nuclear membrane like unicellular, amoeba, euglena, paramecium, which we can call it as protozoa, and also multicellular like animals, humans, and plants. In lesson 2, talks mainly about the general characteristics of living organisms. Actually, the vital processes that happen through the human, animals, and plants. The most important these processes are nutrition, respiration, reproduction, excretion. And how does each process happen inside the body of the living organism, and don't forget to keep well the function for each organ inside each living organism. In lesson 3, we started talking about the microbes. And first, at the beginning of the lesson, we classified the microbes into two types, the beneficial one and also the harmful one. When we started the beneficial one, we started with the roots nodule bacteria that lives in the roots of the leguminous plant to give it the protein and also the nitrogenous substances that cannot absorb from the air or even from the soil by its roots. And after the growth of these plants, they leave their bacteria in their roots to increase the fertility of the soil. Also, the second beneficial one is called lactic acid bacteria, which used in making the yogurt and give it its distinctive color and also its taste. And don't forget that the lactose sugar inside the milk is converted into the lactic acid bacteria that make the yogurt coagulated well, and you can eat it as you follow or eat it well. The beneficial third one of the microbes, we have the penicillium luteatium, that a scientist Alexander Fleming extracted from it the penicillin, and also the Penicillium roqueforti, which we can make the roqueforti cheese from it. The fifth beneficial microbe is called yeast fungus, which is a unicellular organism, and it's used in making yogurt, in making bread, or even enter the structure of the complex B, vitamin B. But the harmful microbes are divided into two diseases are caused by them. The first disease that we have is called the dysentery. Dysentery is caused by one of the protozoa, which is called Entamoeba histolytica, and it's transferred to another person by eating contaminated food. And we can treat it by giving the patient anti-protozoa, as it's caused by one of the organisms that belong to the protozoa species. The second disease is called typhoid, and we know that the typhoid is very dangerous through the health of the cells inside the human body. It's caused by salmonella bacteria, and also it's treated by antibiotic. Let's start in the last unit, lesson 1, starting with the Earth and the solar system. When we started this lesson, we started talking about the solar system by the planets from the distance, the nearest one to the farthest one: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And also we talked about how does the cycle of the season happen, and how does the cycle of the day and night happen, and why the sun appears to move in the sky, and how does the height of the sun affect the length of the shadow. And in ancient times, ancient pharaohs started to use a tool which is called the sundial to determine the time. And don't forget that by increasing the height of the sun through the sky, the length of the shadow decreases, and vice versa. And at noon, the shortest has the shortest shadow. Also, we talked about the seasons, about the winter solstice, the summer solstice, the spring equinox, and the autumn equinox, and you have to keep the day of occurrence of each season. We ended this lesson by the comparison between the winter crops and also the summer crops. Let's start in the last lesson in Unit 4 talks mainly about the lunar eclipse, but when we started this lesson, we talked about the moon phases that happen through the lunar months due to the moon's rotation around the Earth, starting with excellent the waxing crescent, which is appeared like this. From the right side, the four first the first 4 moon phases at the beginning of the month, the illuminated part from the right side, but the other 4 phases from the left side. In lunar eclipse, we started with the first crescent, or we can say waxing crescent, first quarter, more than its half, which is called waxing gibbous, and then the full moon. And let's complete the phases. The part that is illuminated from the left side, starting from the waning gibbous, the waning gibbous, and the last quarter, the waning crescent, and the new moon, which is darkened. Also, we define the lunar eclipse. It's a phenomena that happens when the Earth aligns itself between the Sun and also the Moon in the middle of the lunar months. And we have 2 areas here, shadow area and also the penumbra area. The shadow area means a darkened area in which the total lunar eclipse appears, and when the whole moon lies entirely on the shadow area, the total lunar eclipse appears. But when a part of the moon enters the penumbra and another part is in the shadow area, the partial lunar eclipse appears. And don't forget, the last note of this lesson is very important. It tells us that if all the moon, the entirely moon, enter the penumbra area, so the lunar will be non-eclipsed. This phenomenon is called lunar non-eclipsed. The moon in its ordinary state, and the moon at this moment appears as a red disk. That's for the 4 units for the first term as a quick revision. Just study the lessons well and don't leave any points inside the book, and try to answer different questions with different ideas. Hope you a wish day, and with the best wishes and also a good luck for the exam. Thank you for listening, dear students, and bye bye.